It's really a pleasure to be here at the SWIP conference. I've been following the SWIP conference for many years, reading your papers here and there, and I'm very honored to be invited to talk here. As Agi just introduced, I work at the Wikimedia Foundation, the NGO supporting the Wikimedia movement. We are the organization behind Wikipedia, the free encyclopedia that everyone can edit. Just to make sure, I'm still seeing the title slide, not the current one. Is this progressing for you, or are you going to see the slides? Oh, it's just very slow. Okay. Good to know. So, the vision of Wikipedia is a world where everyone can share in the sum of all knowledge. A vision that partially and in interesting ways intersects and overlaps with the goals of libraries. How is Wikipedia doing with regards to this vision? Wikipedia today is available in more than 300 language editions and provides more than 60 million articles in those languages. But it is really wrong to think of Wikipedia as one Wikipedia. In reality, there are more than 300 language editions, and they are all independent of each other. If you write an article in one language, or change an article, there's nothing that automatically propagates that knowledge to the other languages. This is why the knowledge in Wikipedia is very unevenly distributed between the languages. In English, we have more than 10% of all those 60 million articles. In Turkmen, on the other hand, the official language of Turkmenistan, spoken by more than 4 million speakers, we have fewer than 7,000 articles. That's a factor of about 1,000 in difference. These days, everyone is talking and telling us that knowledge should come from large language models. And I think that it is quite likely that they will play a part in the ecosystem of knowledge in the future, but I don't think that the current architectures support that use case of providing knowledge to people. Let's take a look at a few examples to show the weaknesses of these systems. And I'm basing my examples on ChatGPT, since it's the most widely used chat interface to an LLM these days. And all these examples should be coming from the most current version 4.0. So I asked ChatGPT where I was born, and where was Denny Vrandečić born? And it answers Stuttgart, Germany. But if I ask the same question in Croatia, it gives me a different city. It says Split in Croatia. And since most of you probably don't speak Croatian, here's a proof that my Croatian question is the same as in English. I guess we trust ChatGPT on that, right? So, is the place of birth of Denny Vrandečić one of the big contentious issues of the day, one that warrants different knowledges in different languages, such as the map between China and India, or the nationality of Nikola Tesla, or the origin of hummus? No, my place of birth is not contentious at all, and I could not find a single source supporting one of the two answers. What is going on here? What does it mean for knowledge representation in these systems if the language I ask the question in causes a different answer? Initially, when ChatGPT came out, it simply got the question and then used the model trained on a lot of text to answer the question. And all the knowledge had to be intrinsic in the model. This led to a lot of mistakes, a lot of people made fun of it, and a lot of work went into improving the reliability of the model. Soon, new architectures were created, such as retrieval augmented generation, or RAG. You ask the question, ChatGPT then searches the web or other libraries of content and retrieves relevant documents, reads the documents, and then uses this to answer the questions. This leads to another important question, one that you folk are probably better suited to answer than almost anyone on the planet. How to index the documents in the library for the RAG system? Sure, it's probably different from how libraries do it and probably different from how search engines do it, but it is a billion-dollar question. And I'd really like you to think about it. Let's move on to a question that has been a motivating question for much of my work for the last 20 years. We should have a system that answers questions such as, what are the 10 largest cities with a female mayor? And here's the answer I got from ChatGPT. It lists Los Angeles, that's pretty big. The whole thing looks pretty good on first glance, right? And that's one of the problems with those systems, with LLMs, because they are so good with language. And quality of language is for us usually a marker for quality of the content. So they are so good with language that they are really good at making plausibly looking answers. It may take a moment for you to notice that all these cities that are listed here are in the United States. And this is kind of bias inside the system. It wasn't there in the question at all. So I asked the question again, explicating, I mean worldwide. And there we go, 10 new cities. And again, it looks great, doesn't it? I'm not sure why the result adds an annotation such until recently or former mayor, but whatever. But wait a minute. The previous answer listed Los Angeles with a population of 4 million. And this one lists cities like Berlin or Warsaw in this list. But Los Angeles is missing. On further view, this list doesn't actually look that right at all. Let's ask for the populations of those cities. And there we are. Now we get a list of the cities with populations. Los Angeles is still not listed here, even though it has more people than some of the cities in the list. And wait, the list is not sorted at all. And let's compare it to the previous list side by side. And we see this is actually a different list. Asking for the population changed the list. This should really be another warning about treating these large language models as answer machines. This kind of questions are called global knowledge questions because a single document will rarely have the answer. But what's particularly sad in this particular fact is that we're already using a RAG system. You see on the top that it serves several sites on the web. And there are actually websites on the web which answer literally this question. And still, the system failed at answering it. If I ask a question with such a website, and if I ask a question without such a website in the background, it doesn't have the answer actually pre-made for ChatGPT, it gets much worse. So, for example, here I'm asking for the largest cities with a female mayor in the south of Germany. And the answers are terrible. It first says Munich, and then says Eva Weber has been the mayor of Augsburg since 2020. It's a completely different city. Then it goes on with, and then we have number 3 is Freiburg in Breisgau, but its current mayor is not female. It's like, we're completely losing the track here. The questions are completely incoherent. And if I ask this question in German, the quality of the answer is completely terrible. It's telling me that there are only a few cities, so, which is not true. There are plenty of cities with a female mayor in the south of Germany. And the first one it lists, it's Munich, and gives me Dietlein Grabe-Bolz as the mayor, who was, a few years ago, the mayor in Kassel. Again, not in Munich. There's nothing that connects the Dietlein Grabe-Bolz with Munich. And then it says Karlsruhe with Frank Mentrup, who, by the way, is male, as it says explicitly. And after that, even the language breaks down. And it's all on 4.0. So using those as question answering machines is probably not the smartest way. But here's an intuition I'm trying to build. In 2022, the same year ChatGPT came out, Stable Diffusion was released, another model. It's a generative model to create images. And here are some examples of images that Stable Diffusion has created of more or less famous people explaining knowledge graphs. Maybe you can recognize one or the other person. Stable Diffusion achieves this kind of images with 890 million parameters. That's a measure of how big the model is. Now, you might think 890 million parameters is a big number, But that's almost nothing compared to the estimates for ChatGPT-4, which is 2 generations ago. ChatGPT-4 had about 1.7 trillion, not billion, trillion parameters. ChatGPT-4 was about 2,000 times larger than Stable Diffusion, more than 3 orders of magnitude. Now, is this because natural language is so much more difficult than vision? We know intuitively that this isn't the case. It's because these large language models also include a mirage of all the world's knowledge. These trillions of parameters are storing my 2 different places of birth. If we could kick out that knowledge, these models could be much smaller, much cheaper to run, and with extensions to the architecture also become much more accurate. We could use an architecture where we not only use a library for the retrieval of augmented generation, but also use a structured knowledge base for the kind of global questions, like the Mayer questions that we saw earlier, and use a library of functions for questions that have computable answers. For both of these, Wikimedia offers projects, Wikidata and Wikifunctions. Let's introduce these 2. Wikidata is an open knowledge graph that anyone can edit. It was launched in 2012, 12 years ago, and provides structured linked data and persistent identifiers for many topics of interest. Wikidata is entirely multilingual, and it is used extensively by Wikipedia and many other projects, companies, developers, such as Google, Apple, Microsoft, the BBC, and many more. Also, and in particular, by research teams all around the world. Google Scholar lists more than 39,000 research papers citing or using Wikidata. And there are also quite a few libraries using Wikidata, and I hope you find it useful. They use it for entity reconciliation, for sharing identifiers, and many other tasks. Currently, Wikidata gives information for more than 114 million items described with 1.6 billion statements. Available in 494 languages. How many websites do you know that are available in almost 500 languages? Wikidata is like all of Wikimedia's projects, driven by volunteers. And we have more than 24,000 monthly contributors to Wikidata, and overall, more than 500,000 people have contributed to Wikidata so far, a number I personally find absolutely astonishing. When I started Wikidata, I would have not believed that there are that many people in the world interested in contributing to structured data. Wikidata has so far seen more than 2 billion edits, making it by far the most edited wiki in the world, easily beating the English Wikipedia, which is double as old. And today, I can go to Wikidata and ask for a list of the world's 10 largest cities with a female mayor. We do this using the so-called SPARQL language. SPARQL is a standardized query language for knowledge graphs, for RDF stores. And when we do this query against, it's a pretty complicated query, but if you ask it to the SPARQL query point, you actually get this nice answer here. Now, as before, let's look at the results. And because I was looking at many websites and other results on these questions, I was surprised to see Harbin here on the 3rd rank, a city in China. I looked up the data on Wikidata and found that there was actually a data quality issue, an entity reconciliation problem. The mayor of Harbin was reconciled with the wrong person in Wikidata, getting the wrong gender. But once I found it out, it was quite easy to fix the data, rerun the query, and the result was fixed. Try that with a large language model. There's no way to fix any of the results we saw earlier and have any confidence that the next time around someone comes and asks the questions, they will get the fixed results back. But still, LLMs can and are actually super useful when asking this kind of questions. Because what LLMs are quite good at is to take a natural language question, like the question about the cities of the mayors, and write a query in SPARQL that approximates the question. Not many people know SPARQL, but LLMs can help you to work with formalisms like SPARQL that you don't know. And that's really cool. This works already quite well with ChatGPT out of the box. But in Stanford, a research team around Monica Lam had just published a paper a few weeks ago about a model called Spinach that's really good at the task of creating SPARQL queries. In fact, it got the query for this question right on the first try. I could just run it. All the QIDs were correct, all the PIDs, and so it just worked. It was beautiful to watch. That also shows that it would be kind of easy to integrate a chatbot with a knowledge base such as Wikidata by running queries against it, getting the answer back, and then formatting it correctly. Let's get to the last part of the puzzle. Wikifunctions. Wikifunctions is Wikimedia's first new project since 2012 when Wikidata started. And it is entirely brand new. It just started late last year. The project is fully multilingual, just like Wikidata, but not only in terms of natural language, but also in terms of programming languages, allowing you to implement functions in different programming languages. Wikifunctions provides a library of functions that you can use in many different circumstances. But what is a function? What do we mean with that? What does this mean? So, functions answer questions. And if you have something that answers questions, that's knowledge. They're not the kind of knowledge you would find in the declarative knowledge base, such as Wikidata. It's not declarative knowledge that says this is a structure of a situation. It's computable knowledge or functional knowledge. It allows you to compute the answer to a question. Therefore, it can provide many more answers than Wikidata in general, but only for a specific kind of questions where you can actually have an algorithm that tells you how to get from the question to the answer. And this is what Wikifunctions provides. Here are a few examples of functions that you currently have. This function here calls a Caesar cipher, shifting each letter by a given number in the English alphabet. So for example, if we take the word SWIB, S-W-I-B, shifted by 11 letters, we get the result DHTM. Or here's an example of a function that encodes a word in the NATO phonetic alphabet, and SWIB becomes Sierra, Whiskey, India, Bravo. So if you ever have to alphabetize SWIB to someone using the NATO alphabet, this might be really useful. Here's a function that checks whether a given year is a leap year or not. We check, for example, the year 1900, and it tells me that was not a leap year. Here's one that calculates Celsius to Fahrenheit, and so on. And this variety of functions leads to an interesting question we have where we currently don't have an answer for, and where we could really need your help. I think you are the right people to figure this out. How do we search for functions? Our search currently is terrible. In Wikifunctions, you can hardly find the right functions you are looking for using our internal search engine. But also, how do we help a search engine, such as Google or Bing, to find the right functions? If you look for the NATO encoding of SWIB, well, the NATO encoding page doesn't say anything about SWIB, so the arguments always have to be somehow dropped out and wouldn't be indexed properly and wouldn't be shown appropriately. How do we help a search engine to help the users find the right page on Wikifunctions? How do we help an LLM use the right function to answer questions? How do we index functions? And this question is becoming more and more important as the number of functions in Wikifunctions grows. As of now, Wikifunctions has more than 1,700 functions, with names and descriptions in more than 100 natural languages, with contributors from more than 50 countries. Page views to Wikifunctions are growing fast, nowhere near Wikipedia obviously, but the project is still in a very early stage. We still have a limited number of data types, and we are working through growth pains. Wikifunctions allows anyone to access functions and to answer questions. Today, programmers have easy access to all kinds of functions, but many other people do not. With Wikifunctions, we want to expand the usage and also the creation of functions to enable many more questions to be answered. We aim to allow all people, even without knowing English, to use functions, to create new functions, to implement functions. We think that there is a large pool of potential contributors who have all the skills necessary to contribute functions but don't speak English. We hope to unlock that potential. We hope that Wikifunctions will lead to the creation of a comprehensive library of natural language generation functions for hundreds of natural languages. This will be a major stepping stone towards something we call abstract Wikipedia, where the content of Wikipedia would actually propagate from one language to another. So we are working on a lot of functions for natural language generation. Here are some examples in this direction. This function, given the infinitive of an Igbo verb, Igbo is a language spoken by more than 30 million speakers in Western Africa. Given the infinitive, it generates the regular imperative form. This was created and tested by Igbo speakers, and they were able to deploy this function on the web and made it accessible to everyone else. It was beautiful to see the shine in the eye of an Igbo speaker when I showed her this function. We were talking about her, and she was just so happy to see, for her language, to see natural language generation function that everyone can just use on the web. Something that would have been much, much more difficult without Wikifunctions. Here is a function working on English terms with an irregular form. It's asking basically for a given word like goose and returns to the plural of it, geese. Picking up the correct form from Wikidata, where the lexicographic knowledge is recorded in a declarative way. So we can mix this kind of generative functions that create the regular forms, but also look up for the irregular forms on Wikidata to see the lexicographic knowledge and to choose the correct form in both cases. Here, for example, we have a function that creates the English possessive. And these functions are demonstrating how functions and declarative knowledge can live side by side. The goal then here is we can think of more complex functions that bring those together. For example, to express the south of Germany. So we want to say the south of Germany. The one argument is the cardinal direction, like south. The other one is Germany. And you want to express this in English, and it says it the south of Germany. Or I can switch in, for example, and say it now in German, and it says the Süden Deutschlands. Or I can do it for many other languages and get accordingly the creations. And we can build many such functions that are creating the building blocks of natural language to create more complex expressions. Such as this one. Eventually describe a complex concept like female mayor in southern Germany, for which we don't always have a QID identifier. Wikidata doesn't always have to say this is an entity. Our goal is to describe such concepts so that we can generate text capturing the meaning in many different natural languages. Our goal is not a formal specification of a set theoretic meaning. That's not our top priority. Although if it happens, I'd be very happy and we won't say no if it works out. Sometimes these concepts that might have a QID, might have an identifier, sometimes they don't, even though they look structurally the same. And that makes the knowledge representation tasks somewhat challenging. But many of the things we talk about in Wikipedia are like this. They are like these complex concepts, as you say, like these complex descriptions. And we need these for representative knowledge in Wikipedia in order to actually speak about it. This is one of the big drawbacks of Wikidata, that we actually cannot talk about such complex concepts. There's no way that we can actually express a sentence like Käthe Winkelmann was the first female mayor in southern Germany. And we need those concepts, obviously, to make the sentences for Wikipedia in order to build this new architecture for Wikipedia. Because these new abilities, these natural generation functions, are necessary for for the Exec Wikipedia project, where we are working on a frame-based representation of a much larger portion of the knowledge in Wikipedia in order to turn it into text in many hundreds of languages, so that a change for a contributor in any one language of Wikipedia will automatically propagate to all the other languages of Wikipedia, which will allow us to come a significant step closer to closing this knowledge gap we have mentioned earlier and creating millions of articles in hundreds of languages. We have seen with LLMs translating questions to SPARQL that LLMs can be quite good at translating into formal languages. And that allows us something new, something that hasn't been feasible before. We can introduce new and more complex formalisms of knowledge representation for our knowledge bases, which deal better with brittleness, with exceptions, with fuzziness, and yet require less training for humans to deal with this more complex formalism. I think we can use LLMs to start a new golden age of knowledge representation in which we can get closer to the expressivity of natural language than we ever did before. And on the other side, we need to figure out how to index and search for knowledge in knowledge bases in a library of functions so that LLMs can do so effectively to access knowledge in libraries and documents, in structured knowledge bases, and in libraries of functions in order to get one step closer to a world where everyone can share in the sum of all knowledge. Thank you for your attention.
Thank you so much, Denny. That was very, very steep learning. Sassy Advent echo. Yeah. Yeah, me too. Yeah. Okay, that's better. Thank you. Right, so please, if anyone has questions, as I said, post them into the chat, and here's the first one. Are there advantages to having the volunteer communities around Wikidata and Wikifunctions contributing to these systems rather than employees of a company? That's been Simon.
Yes, there are huge advantages to having the volunteers contributing. Most importantly is that I've been on both sides, right? I've been working at Google and I've been working at the Wikimedia Foundation. So at companies, the decisions of having people contribute to this kind of knowledge bases will always be decided with a view on how profitable this is. So it's not about reaching as many people as possible, to bring knowledge to as many people as possible, but rather, is there a profit in opening up this market? Is there a profit in making this knowledge available to this group of people and so on? Whereas with volunteers, we don't have to think about the profitability of sharing knowledge, but we can think about this. We can be driven by this genuine wish to allow everyone to share in the sum of all knowledge, and to allow everyone to contribute to this knowledge and to build there. We still have huge limitations because it's a time of volunteers and it's the ability, how can you organize the volunteers and allow them to work together effectively, and which is something that the company has obviously figured out much better than the most volunteer groups. But nevertheless, we don't have the same restrictions that companies have with regards to organizing this kind of work.
Yeah, I think when you say that we wish to make information available to everyone, that's right up the alley of libraries. And also, I was really fascinated by Wikifunctions. I think that's brilliant. I'm just wondering, because libraries have for decades already had this discussion of, okay, we can't even get our users to use the advanced search or even Boolean operators. And what you showed was certainly an improvement, but still you have an interface where you need to look at least once how to use it and then click stuff. And we didn't even get people to do that. So how do you think we can still bridge that gap of whatever it is, accessibility, laziness, fast food information?
Oh, that's a great question. We actually don't know the answer to that one yet. I know that we will have to somehow figure this out. For now, we have 2 use cases that we are aiming for, where we bridge this gap a little bit naturally, because the first use case is we're using the functions in order to build Wikipedia articles. So in that case, it's not the end reader of Wikipedia who have to call these functions, it's the contributors to Wikipedia, which is a differently motivated group and might be able to actually figure that out and use it. The second one is that we might, for example, put the right function in the right place inside Wikipedia in which interacts with the article. And there's like the big question, exactly what you're asking. Will people actually click on those things? Will they enter arguments? Will they use these functions? We don't know. It might be interesting to make Wikipedia more interactive, but we have no idea if they will actually use those. The answer that I'm really looking for is actually to, I hope that, and this is where LLMs come in as well, and that LLMs will provide us with a natural language interface where you can just ask a question, and then it will actually automatically pull in the right function, pull out the arguments, and provide the answer for your function, and then just give them back. Basically, you don't even know that you're using something like a function in the back end, but rather it's integrated on the chat interface that we are using.
Right. Okay. Yeah, I'm excited to see how that progresses. I'm actually also would be excited to see how the Pope explains knowledge graph. I think that would be great. And then another question that I have is, you said that libraries should really think long and hard about contributing to retrieval augmented generation by providing metadata. But now the problem is that libraries are also still new to this field, and now we all have the question, like, should we like proactively just generate metadata for RAG-based use cases, and how would that even look like? Like, what format should we use? We can't churn out metadata if we don't know what it should look like in order to be best usable by LLMs.
Thank you for this question. I just want to refine what I meant. So I don't think that the goal is just to provide more metadata or something like this. The goal is actually to figure out, and this is why I think that librarians are actually really well poised to figure that out. The more complex questions of how actually does the indexing work? How should the metadata even look like for this kind of use cases? I don't think anyone knows that at this point. So that sure, we can create more metadata, but we don't know if this is actually a good thing, is this a useful thing, or what, because we don't even know yet how exactly this metadata should look like. How do we, because Google has been working for 2 decades on how to index the web for search queries. So we have kind of an understanding of this space. But of the space, how do we index a large set of documents for an LLM? I don't think that we actually understand this space at all yet. And it's even worse for the functions. Neither for search engines nor for LLMs we actually know how to index the space of functions yet and how to make those findable. Because in the end, we saw that most LLMs will like take 2 or 3 documents and read those and try to answer your question. So if the answer isn't exactly in those documents, it still won't actually find it in many cases. So we need to be somehow able to annotate, we need a secondary system that indexes the documents in such a way that given a question, we find the right document. And I think this seems to me something like that librarians have been working on for several centuries. And so no one else probably has as much experience with this question as you do. But it's still different from what we're doing right now. And I don't think anyone knows the answer yet, how this exactly will look like, if that makes sense. I would actually like to hear back from you as experience in the area, as a subject matter expert, if that makes any sense to ask this question.
Absolutely. I think we're still trying to make sense of it ourselves. And there's one related question. How do you think libraries and related institutions, e.g. archives, are going to be used in the future? Will it be through a chat interface like ChatGPT?
I think that the chat interface like ChatGPT will accompany the current user interfaces to those documents. I still hope that we will be able to actually access the real documents, the actual documents if needed and so on. Because I mean, this is the source of truth and everything. And particularly right now in the last 2 years, and I'm not seeing this change too quickly, I don't trust anything a chat and LLM actually gives me as an answer. When I get an answer from them, it's like, okay, this looks interesting, but now let's try to figure out if this is actually really true. And then I do another round of searches in order to find any document that actually supports that. Having the actual documents, being able to pull out the actual references on will be tremendously important. So it will change the way we access it. And I do think that things like LLMs will mediate part of the experience of accessing libraries and other archives. But I don't think that we know yet how exactly our mode of accessing this kind of libraries will be in the future. And it's something that we still have to figure out together. I hope it won't be just a competence in California defining it for everyone, but rather that we're all working together on figuring this out. But yeah, for sure we need to think about this.
Yeah, I also hope that people will. So I think that we cannot completely reduce the complexity of structuring information. And I mean, what previously was the expert search now becomes how do you do proper prompt engineering, or how do you formulate a question, understanding how information needs to be structured in order to find stuff. And the hope that the machine will just guess what I mean is, I think, futile. So yeah, I'm also interested to see where it will go. There's another question about the present tense or present time, actually. So what about existing Wikipedias? Could this fix contradicting facts in different languages as well? So here we're talking about reasoning again.
This is not what we are working towards, because for that we need to be able to parse and understand natural language on the existing Wikipedias. So I think that the current progress in LLMs will allow to build such systems, but abstract Wikipedia isn't exactly built towards it. It's more about filling gaps inside of Wikipedia. Also, I am very, very uneasy with the idea of any system automatically fixing errors in Wikipedia. I very much prefer a system that, if it detects inconsistencies between different language editions, for example, that it puts them on some list, that it tells it to someone, and then someone can actually go in and figure out why is there this inconsistency. Is it because one of them is simply wrong? Is it, which would be the easiest case? Is it because, both of them were representing only half the truth, or is it because there's an actual disagreement? And I would like to have a human editorialize basically those differences, because I think in many cases the world is just more complex than we usually assume. And having contradictory answers in different languages doesn't always mean that just one of them is wrong or whatever. It can often also be an indicator that the situation is just more complex.
Or that we have different worldviews, actually. Maybe even. There's some linguist hypotheses about that language forms thinking and we don't know. So yeah, interesting thought. Here's another question. I'm trying to interpret it. When we make, for example, books available online in a digitized form, no special attention is paid to back of book indexes. Maybe this could be a factor in building indexing of texts But what I think is that would maybe be like already using a certified index that exists as a knowledge base to keep, for example, an LLM from indexing the same thing over and over again. That's kind of a form of RAG, but with indexing. Anyway, I'll just let you answer the question before I hypothesize what it is.
I'm happy to go with your hypothesis. No, I think that indexes are parts of the book matter which came from a time where we didn't have full text search and so on. It's not my specialty about indexes, but I assume that there has been some soul searching in the world of indexes about what is actually the point of indexing given full text searches and so on. And I can totally see some usefulness, because a human index is different than just, saying this word has appeared on this word. It's actually about saying those things are more relevant and here's the thing you look up. And I do think that a similar jump we need to do for LLMs, where we don't index just the knowledge on a page, but also what kind of questions does it answer. Because in the end, we have the natural language question coming to the LLM, and then the LLM currently it turns into a search query, runs it against a document corpus, gets the top N answers, puts them into the context and answers that. So we have here a very classical step inside, doing this search against a corpus, and we assume that the LLM knows how to properly query that. I don't think that's correct, and I don't think that the current way we are indexing documents is sufficient to actually provide the most effective way to get to the right documents in the right time.
Right. Okay. So I have one last question, maybe on a strategic or even political level, is that we as libraries know that it's important to also have like the symbolic modeling of the world or explicit knowledge. But the world, it seems, or it feels like, doesn't seem to see that at the moment, because Gen AI is all the hype. So what can we as libraries, we're not listened to much anyway, so what can we as libraries do to educate the public?
That's a great question, and it's an important question. First, I completely agree with the premise. But as you say, Gen AI is currently all the hype. It looks like, and it's difficult to argue that there's a lot of stuff that these technologies will enable. But also they've always said, hallucination, all these problems, this is something that will go away very quickly. And we haven't seen basically any progress in that area for the last 2 years. But at the same time, I'm actually having the exactly same problem. I can't formulate an intuitive explanation of which kind of questions are okay to ask an LLM and which kind of questions you should be very careful if you ask an LLM for. As a kind of a specialist in this area, I have an idea for myself, like which kind of questions are fine and which, but I can't express it in a way that sticks with people who are not experts in that area. My brother asked me that basically 2 years ago. He's totally not someone who goes for the newest technical trend. But he asked me 2 years ago, like, oh, shouldn't he just use LLMs here, and instead of things? And I'm like, no, this is completely wrong. Use it here. And then he asked, oh, what do I do with this? Oh, for this one you can totally use it. And he just doesn't understand. You can totally use it to make your CV read a bit smoother. That's fine. And then you check again if it maybe did something wrong. But don't ask it for how many milligrams of ibuprofen you should give your sick child when it has a fever. Because that is not something that you should be asking the LLM. The different kind of questions are extremely difficult for me to express in a way that is understandable by the general public. And I think as long as we don't have a way to say, yes, LLMs are great for this, but not for that, and to differentiate this and that, we're going to have trouble to even make this argument, because how do we even talk about the topics which are good and which are not? I've been struggling with this. I'm pretty sure many of you have been struggling with this as well. And I think we need to find somehow a way to get towards an answer before we can really be effective in the political way, because otherwise we can't actually reach the wider public, which is really important for this kind of things, for the perception of these kinds of technologies in some way.
Absolutely. So maybe we will have a collective learning curve and see where we are in 2 to 5 years. So thank you very much again. There's another question that maybe you can ask or answer in the forum. Somebody wanted to have the link for the SPARQL Query Builder. Is it part of spinach.ai? And thank you very much again for this keynote.